Hello children, today we are going to discuss about continuous charge distribution. So far we have seen the amount of force exerted by charges or the field exhibited by a charge by using single charges, by using unit charge, right? Single charge. We took a single positive charge or a single negative charge when we calculated the field, and when we took two charges, we were able to calculate the force between the charges by using Coulomb's law. All these discussions we have done in the previous classes. But do you think that in practical applications, we will be dealing with only one single charge? Can we be able to calculate the field or the force exerted by using the mechanism to calculate for a single charge? Is it possible? No, right? In practical applications, in real life scenarios, we will see continuous charge distribution. We cannot take single charges for calculation. The purpose of using single charge and doing all the calculation is to make mathematics simple for you. We do not want calculus when we are dealing with single charge. We are not using calculus there because the calculations are very easy when you are dealing with single charges. But when you deal with continuous charge distribution, you will be requiring the involvement of calculus for calculating the charge distribution for a entire surface. So continuous charge distribution is a system of closely spaced charges. For example, now if you take a wire, you all know a wire, right? If you take a small wire like this, there will be charges all over the wire, continuously distributed, right? So this is a continuous charge distribution. If you take a sheet, charge will be distributed all over. So this is a continuous charge distribution. So when I know the dimensions of this charge, dimensions of this sheet, if I calculate the charge in a particular area, then I can integrate it to find out the total charge distribution by using the limits. Similarly, for a wire, if I take the calculations, if I do the calculations here, then I can integrate it from the lower end to the upper end by using the limits. This is how we are calculating the charge distribution in a continuous charge distribution. In a place where the charge is distributed, continuously it is present. Okay. So now we can classify this into three: line charge distribution, or surface charge distribution, or volume charge distribution, based on the nature where the charges are distributed. One important thing we should notice: charges are expected to be distributed uniformly. Only then you can integrate. Otherwise, for each, you have to do it separately. So we expect the charges to be distributed uniformly. Now the first one is linear charge density or line charge distribution. Both are same. Okay, so if the charge is distributed over a line, then the distribution is called linear charge distribution or line charge density. Okay, both are same. So now this is the wire that we discussed in the previous page. We are taking a small portion here, which is called dq, for a small length dl. So linear charge density or line charge distribution is indicated by the letter lambda. Okay. So lambda will be given by dq by dl. So when you wanted to calculate the distribution for this entire wire, we are using the limit so that to integrate it. So you will get it as q by l. Total charge divided by the total length of the wire. Okay. So lambda is equal to dq by dl means in finding the charge distribution for a small area, then integrating it throughout the length of the wire. Okay. So if the charge is distributed over a wire, we call it linear charge distribution or line charge distribution or line charge density. The linear charge density is the charge per unit length. SI unit of charge is coulomb and for length it is meter. So the SI unit is coulomb per meter. Okay. With this understanding, we move on to surface charge density. Surface charge density is indicated by sigma. Remember surface sigma, okay? And line lambda. So if the charge is distributed over a surface, that is like a sheet, any metal sheet or anything, then the distribution is called surface charge distribution. Here as it is surface, we take it as dq by ds. There it was line, so we took it as dq by dl. Here as it is surface, it is sigma is equal to dq by ds. And when you are integrating it for the entire area of the sheet, you will get it as integration of dq by ds will give you q by s. Q is measured in coulombs, surface area in meter square. So the SI unit will be coulomb per meter square. Okay. And coming to the third one, it is volume charge density. It is denoted by rho. Don't confuse it with the specific resistivity. For volume charge density, you are using the symbol rho. Okay. If the charge is distributed over a volume, then the distribution is called if the charge is distributed in a particular volume, we call the density as volume charge density. Volume charge density is indicated by rho. Okay. So, you can see the figure. We are taking a small volume and we are calculating the charge per volume there. That is rho is equal to dq by dv. So to find out the charge distribution for this entire volume, then you can integrate it. So you will get it as q by v. Again, charge is measured in coulomb, volume in meter cube. So the SI unit is coulomb per meter cube. Okay. This is how we are using continuous charge distribution. You have to remember the terms and how to measure it either for a line charge distribution, surface charge distribution, or volume charge distribution, because in the upcoming topics we will be discussing about continuous charge distribution, so that this will be useful to you in those topics. I hope this concept is clear to you regarding continuous charge distribution. If you have any doubts, please raise in the comment section. We will be happy to help you. Thank you.